I'm James Johnson, and you're watching Niagara Pro Tips. Hello, and welcome back to Niagara Pro Tips. In this video, I'm going to focus on talking about smart tags and relations, and specifically, I want to have a use case example here related to schedules being linked to occupancy points and how we can utilize those relations perhaps in air handler graphic or a schedule graphic to help understand what things might be connected to a schedule. So in this example station, I have this Greenbrier station here, and it does have a lawn network underneath it with multiple floors, and there are air handler devices under each floor, and under each air handler device there are points, and under the points container there is an occupancy point. And this is really what I'm just showing here in this PX graphic as well, so I can try to maybe illustrate a few points there. Now, as far as the schedules go in this station, I have a home folder here with a schedules subfolder, and there's a number of schedules underneath that, and these are all different weekly schedules here, including maybe this one as well. When we talk about schedules, and those are linked to control points, it's possible that the schedule may be directly linked to a point. However, it's probably also equally common that the schedule is linked through some other logic, whether that might be a selector block or some other logic, and then ultimately gets linked to a point which is controlling occupancy maybe in that device. So it's not always a direct connection from the schedule directly to the point. And for that reason, it might be useful to have a smart relation which is somehow able to determine what the schedule is linked to at some endpoint and have an idea of which things are being controlled by it. And it's not always maybe a simple task to try to understand that. The other thing about NQL is that NQL can query for relations but not data links. So with NQL in a PX view or a hierarchy or things like that, I can't really leverage these data links directly because NQL doesn't query those directly. So the idea here, I guess, in trying to illustrate this a little bit more, is that we have this network of devices that have these occupancy points perhaps that are linked to the schedules, but they may not be a direct relationship going from the schedule to that point. And what we want to do is create a smart relation somehow that will then allow us to easily tell what this schedule is actually connected to. And in order to do that, we're going to need to set up some tag definitions and use a few tags here in particular. Whenever you're setting up tags in a station, it's very important to define those tags in your dictionary. So in this case, I have a smart tag dictionary, which is called my building dictionary, has a namespace of B here, and I already have some tag definitions. Now, I want to add some tags to these schedule components here because these do have tags on them, like an end schedule tag, but end schedule tag applies to every kind of schedule, not just a weekly schedule. So we want to be a little bit more specific maybe with a tag on the schedule. And also obviously some tags on these occupancy points which are underneath the device. And so the first thing I'm going to do here is under my tags in my tag dictionary, I'm just going to drag out a marker tag here, and I'm just going to call this weekly schedule so that I'm just defining the fact that I'm going to have a marker that's going to indicate something's a weekly schedule. I just want that in my tag definitions so people who are using the dictionary or accessing the station know, hey, this is an expected tag that might exist. Now, the other thing we want to do is I want to have a smart relation that can relate the schedule to the points. And in this case, I have a smart that's in my Vicom Pro palette, and this is a weekly schedule relation component. So the idea here is I'll just drag this out into my relation definitions in my dictionary, and I'll give it a name, like schedule ref will be my relation ID. So it'll be B:, because that's my tag dictionary namespace. That'll be implied, and it'll be schedule ref will be the relation ID for that smart relation there. Now, once I've got the tag definitions set up and the relation definitions set up here, then I can proceed to setting up tag rules. And I've already got a couple tag rules here. I was just trying to sort of cut down on the time a little bit, but I'll show you what I have here. So using the tag dictionary and the rules subfolder here, I used an AND rule and drug that out, and I set up the conditions from the conditions subfolder here. And I'm looking for an enum point in the station where the name equals occupancy. So that will find these occupancy points in the station. And I already have a haystack tag dictionary in this station as well. I'll show you that under the tag dictionary service. You can see there's a haystack dictionary there. So I want to use this tag rule actually to apply the HS occupied and HS command tags to those occupancy points. Now, the other thing I need to do here is I want to have that smart relation get created on these occupancy points. So what I'll do in that case is I'll drag out my weekly schedule relation onto the relation list here, and I will assign it that same relation ID that I set up under my relation definitions, which will be schedule ref. All right. Now, once I've got the tag rule applied to my occupancy points, the other thing I want to do is I need to apply the tag rule that's going to apply to my weekly schedule components here. So again, in this case, I drug out just a Boolean filter rule, and I'm looking for anything in the station which has that end schedule marker tag on it, which will be any kind of schedule, and like a trigger schedule, a weekly schedule, a day schedule, and so forth. And then I'll check the name tag here to have a regex pattern of something ending in weekly. So that should pick up on all of these schedules here, as well as this global Boolean weekly schedule. So any schedule which ends in weekly on the name should be picked up. So in that case, what I want to do is use my, and you can copy from your tag definitions, or you could drag out from the tag dictionary palette, but basically I want to apply that weekly schedule marker tag from my building dictionary to any of those schedule components in the station. And then I also want to assign that weekly schedule relation, and I will type in the schedule ref as my relation ID that I want to assign to that smart relation. And that's really about all there is to it, at least as far as creating the tag definitions, the relation definitions, and then setting up a tag rule to apply the relation to these occupancy points and also to the potential schedule which they are connected to. Now, once I have those tag rules applied there and everything, I should be able to take a look at those relations now. And the implied relations don't show up on the relation sheet, right? Those only show the data links. So if I were to look at the relation sheet, I'll see the data link that's coming from, in this case, the schedule selector. If I go to the SPI remote view on the occupancy point and then take a look at my implied relations, I should now see that I have an inbound BqlSchedule ref relation from my first floor weekly scheduler. So the smart relation was able to look through the data links that were coming into the occupancy point and resolve that source component as being the first floor weekly schedule. And looking at the wire sheet here, this first floor weekly is not linked directly, rather it's linked through that enum schedule selector. And part of the idea with this smart relation is that it's dynamic to understand what it might be linked to, essentially. If I go into the schedule selector and I change that to, say, the second floor weekly schedule, then I'll notice that the schedule selector is now linked into, or linked from, the second floor weekly schedule. I go back to my Air Handler 3 occupancy SPI remote, and this currently, because it's a static information, right, it says first floor weekly. If I refresh the SPI view and then take a look at my implied relations, I should see that my schedule ref relation now says it's coming from the second floor weekly schedule. So that relation is implied. It gets resolved anytime something queries about the relation. So it should stay up to date with whatever kind of wire sheet and logic linking and things that might be changing at that level. And if I take a look at the SPI remote view on one of the schedules, we should see it has obviously the knobs, which are the data links that are going out to the actual occupancy points or schedule selectors and so forth. And then if I look at the relations, you'll see that this schedule has a number of outbound BqlGrid ref relations out to various control points in the station. So that is just proving that that smart relation exists both from an inbound and an outbound perspective. Now, how can I utilize these relations then? What's the whole point of creating this smart relation between the schedule and the occupancy points? So in this case, I have a relative PX view, which is assigned to all the air handler devices in the station. And I have a button here with a value binding, and currently the hyperlink property is just set to null on this. So what I would like to do here is to utilize Nequal to find the occupancy point, which is underneath the device, right? So this graphic is currently assigned to air handler 3. That's my relative starting point, and from there I'm trying to find the occupancy point here under the device. So to do that, we could utilize Nequal, and we could search for the HS occupied and HS CMD marker tags, right? And then I would use the single ORD syntax here, the single scheme here on the end of the ORD, because this is going to resolve to a Nequal query, which is a BQuery result, and then I'm telling it, give me the single item out of that query result, or the first item out of the query result. So what that would do is when I click this button now, that takes me to the property sheet of the occupancy point underneath the applicable air handler. And that's not exactly what I'm trying to do, but it's a baby step and it gets me in the right direction. Now, once I get to the occupancy point right here, now I have an inbound schedule ref relation which comes from whichever schedule is actually controlling this particular air handler device. So I should be able to leverage that schedule ref relation to then get to the endpoint, which in this case is the schedule. So going back to my graphic and into the hyperlink property here, I can take the results of that resolving that Nequal query into a component, and I can tell it to again use a Nequal statement here, and I can tell it to traverse the BqlGrid ref relation, which is inbound to this control point, right? So it's coming from the schedule to the control point inbound. And then once I resolve that relation, then I just simply do a pipe single colon again so that it actually resolves that endpoint, which is the schedule. So you can see, I'll stretch this out and you'll see what the entire ORD looks like together with the two Nequal statements together, right? So the first Nequal statement searches for the HS occupied and HS CMD tags, resolves that endpoint, which is the occupancy, and then it uses Nequal to traverse the schedule ref relation, which is inbound. That's why it's the less than dash symbol, inbound relation, and then the single scheme to resolve that end component as well. So now when I click on this button, that should take me to the graphic for the second floor weekly schedule, because that is what the schedule is currently, or the schedule selector is currently selected to or linked to here. If I were to go back into the schedule selector and change this to first floor weekly now, and looking at the wire sheet again, the schedule selector is now linked into that first floor weekly schedule, and then it's passing the link outbound to air handler 3. So if I were to go back to the air handler graphic without changing anything in the graphic, and I click on the schedule button now, it takes me to the first floor weekly schedule, because it's following that relation which it resolves at the time of the hyperlink being clicked. Okay. Now, another aspect here maybe is utilizing maybe a BqlGrid component from the report palette. The BqlGrid component, I'll just copy this and paste it under my schedules folder here as an example. And then taking a look at the AX property sheet here, we can build up a query. And in this case, I'll use the component chooser maybe and narrow this down to the LAN network as a base ORD. And then I'll use an equal query for HS occupied and HS CMD. So that's going to find those points, right, that have the occupancy tags and everything on them. In this case, you can see there's 76 rows in the result, right? I just want to prove to you that it's finding all the occupancy points under every air handler in the station. Now, what if I wanted to find only the occupancy points which were related to that first floor weekly schedule? What we could do then is say and B: schedule ref relation inbound. So that's going to find all of these occupancy points in the station under all of these devices, and then it's going to check that they have an inbound schedule ref relation, and it's going to traverse or follow that relation to the other end. So it's going to be finding essentially any of these schedules that might be linked to those occupancy points. And then we can check the name tag on that schedule component and see if it equals first floor weekly, for example. What that should do is then limit those results down to just the items which are related to this first floor weekly schedule. Now, each one of those rows is really pointing to the occupancy point, right? So if I go to the AX grid table here, obviously the that's what happens when you're doing demos sometimes. The BqlGrid is expecting a BI table result, and the equal query is a BQuery result. So what I would need to do is pipe this into a BQL query. So something like BQL select, and I could say maybe parent.display. Gotta type the name correctly. Display name as say equipment or something like that. So that's just a BQL projection that's starting off at the control point, which is here, and it's walking up one parent level to the points container, another parent level to the air handler device, and then it's getting the display name of that and then aliasing the column as equipment. So then I can click on this and see the results of it, and so that does give me the BQL table results there, and I should be able to take a look at the grid table view here, and you can see now that it's showing me all these rows. Now, in this case, when I double click on one of these rows, that takes me to the control point, because that's the extent of that query, is that we're finding the actual occupancy points which are related to the schedule, not the air handler devices. The BQL projection is just showing us the name of that device. Okay. So the idea, though, is with those component grids, what we can do is we can embed the component grid into a graphic. And I'll just delete. Oh, I guess I didn't need to delete that one out, but I'll just show you this one. It's actually a different BQL grid that's in there, but when you look at a BQL grid that you've embedded, it has a hyperlink property here. And this hyperlink is a relative hyperlink that defaults to slot colon. So in this case, I set up a relative backup hyperlink. So ... walks up one level, / ... walks up a second level. So even though the grid is finding these occupancy points, the hyperlink I can configure to be a backup port that would walk up to the device level there. Okay. So you can see then the BqlGrid results are loaded here, And each of these, now they're orange because, by the way, these LAN devices are down and they're not really communicating anything. These could obviously be BACnet devices, Modbus devices, or anything else. But in this case, when I double click on the row, that actually takes me to the equipment graphic for that piece of equipment, which has an occupancy point, which is related to that schedule. Okay. So hope you found this information interesting and have some ideas about how you might apply this type of solution to your projects. And you can do that utilizing that weekly schedule relation from the Vicom Pro palette under the relation folder. And you'd have to just set up the tag rules like I showed you similarly to assign that implied relation, that smart relation I should say, as an implied relation to your occupancy points and to your schedules. Now, stay tuned for additional Niagara Pro Tip videos, and I'll be doing another video explaining how to utilize the same type of smart schedule relation to build hierarchies both locally in the JACE and also at the supervisor sort of enterprise level hierarchy leveraging system database. So stay tuned and have a wonderful day.